IBM is a series sponsor of our ebooks on Docker and the container ecosystem. Learn more about IBM's perspectives on these timely and important topics in our latest ebook about application architectures and microservices. It's available for download at thenewstack.io.
Hey, it's Alex Williams here at the New Stack here at Dockercon, and I'm here with Andrew Haley of IBM. Nice to see you, Andrew.
Yeah, good to be here. Thanks.
Great. This is one of those interesting events where you have a lot of companies of all characteristics here. You know, you have the very young companies. You have Docker, which has established itself, in the market, and then there's, the providers such as IBM that are here. I guess I'd like to just start by talking about what are the shifts that brought us here, because what we're talking a lot about at a conference like this are these issues and subject matters around scale. And IBM has a long history of understanding scale. And so perhaps we can just start by setting the context from IBM's perspective about the Docker and container ecosystem and the shift to scale that IBM as a company has seen over several decades.
Sure, it's a great topic, one that's really close to my heart. And we've sort of see two major shifts in terms of what people are building with cloud technology today. And on the one side, it's a business shift, right? It's about speed of delivery of new capabilities. And there's a lot of pressure in a lot of companies to innovate faster than a company they may not even know will soon become a competitor in their space. And we can look around the industry and we can see lots of cases where it's actually, the mobile experience or a new generation of applications has really just redefined an industry or disrupted an industry entirely. And we've seen it happen in places like the hotel industry with the shift to web properties for booking, then to mobile apps, then to people putting their own homes out through a number of channels. And suddenly the market flips around completely on a totally new user experience. And it's that search for that new user experience that responds at the speed and in a way the consumer likes is one of the major driving forces.
Response to speed.
Response to speed. I mean, it's not about taking 2 hours at a travel agent or even 10 seconds on an internet site searching for a hotel. It's about getting results in 2 seconds based on your location preference and maybe something I've learned from your calendar on whether you want to stay in a hotel or a rental property or sleep on someone's sofa or whatever. And people who figure out those right user experiences by experimenting with their end users, those are the people who are changing the industry. So when you look at the people who've gotten investment, their main priority right now is figure out how they bring more customer experiences faster and then iterate on those. What we see in Docker is a set of tools that the developer community gathered around because it enabled them to iterate at speed. Right? The excitement in the ecosystem is that this was a very simple set of tools that let them build all these front ends or let them take their application and break it down into little pieces or containers, iterate on all those independently, and they could actually then test their ideas much faster through the whole development lifecycle, put them in production, get user feedback, and rebuild whole applications in a very short order. So I'd say that's sort of trend one is this business pressure around speed to learn what the new engagement models are with customers and build the apps that do that. The second one, if we want to get into that, is really about the changing nature of how people code today. And there's a lot more sharing of ideas. We've seen it with the explosion of open source, but we also see it when we go to universities, that the default way to solve a problem is probably in an online forum. Right? It's not a whole bunch of individuals carving projects up into little bits. It's a whole bunch of people working collaboratively on the same pieces of code. And again, that's completely changed the way that project schedules are built. It's changed the way people work together, and it's required this new set of tools again. So that collaborative coding, that leaning towards being very open and collaborative, has drawn tons of people into these open communities. And the more open the community is, the more vibrant the community is. We tend to see those technologies take off really fast.
Do you see a historical context for that as well in terms of IBM's history with open source technologies?
Yeah, and I think we're seeing another kind of renaissance moment in the technology industry. I would say that the last really big one that felt like this was the shift towards internet and e-business. And that started with some very foundational open technologies. It was the specifications for the internet protocols, HTTP, HTML, things like that. But the real accelerant there that we don't often talk about is the actual implementation of those technologies. And the internet was a very awkward place to navigate when we started. You would go with one browser to one web server, and you would get a different experience if you changed the pieces on either side. Every web server was feeding content in a different way. Every web browser was interpreting in a different way. There was just enough lack of detail or lack of adherence to specification that we started to learn early on in the days of the web that it became about sharing the implementation. And the Apache web server was one of the first projects IBM jumped into in that era. And we saw an immediate explosion of websites based on that open source technology. Because it wasn't about arguing over who got the implementation right of the spec anymore. It was about a whole lot of people rallying around that one implementation to make it fast, to make it right, to make it scale. And it took off in such a way that there was at one point over 80% of the internet traffic was being served by this one implementation. And what it meant is we got to move on to the next problem. Right? Then we got to move on to making websites about transactions, and making them about business, and moving into the Java open communities. But we learned by sort of rallying people's energy, not around creating 50 implementations of basically the same thing, but getting them to agree on some of the core pieces and implementing them one way.
And that seems to be right at the start of that era that we know now as the read-write era is what I think of it, how I think of it as, right? Where the internet was a very traditionally in its beginnings was very static, and it had there was I think Tim Berners-Lee was saying that he wanted it to be a read-write web, and that was his dream. But at the beginning, it was very static, and then we started to see with these internet and e-commerce environments, like you're saying, these transactional type of systems, which had a level of read-write interaction through the transaction itself, but we did not yet see the read-write movement that came with, for instance, the introduction of RSS, right? And RSS then leading into like the API movement, and the API movement leading to many places where we are today. Where do you trace it back, for yourself to get a perspective of the Docker and container ecosystem today? Because I often think of it as like the time around 2006, 2007, but you could argue that it was much earlier than that. There was actually, you could argue it was much earlier than that, but in a modern sense, in like the past 20 years, is there another point that you look at that you think about when you think about the ecosystem where we are now, and as a kind of a seminal kind of event?
Yeah, in terms of, container technology, I think the seminal event was some of the mega scale social web properties, right? And it goes back probably 10 years, right? The idea of needing tools and open, development tools, that really emerged out of the transaction area. If I look at 2000 to 2005, we realized that things like Eclipse needed to emerge so people would have an open way of collaborating. There'd be a lot more agreement on how people built things. As we got a lot of maturity in building those kind of applications, there was a new, very scaled up set of social services being launched. and they needed something very different in terms of hosting technology, where they could adapt extremely quickly to changes in user demand. I mean, the closer you get to the end user and being relevant to them in their daily life exactly at that moment with a technology service, I would say to some extent the more unpredictable the load becomes, right? You don't know if today they're going to be searching on Britney Spears, and tomorrow they're going to be searching on the Rolling Stones, so, as a throwback, and then right after they're going to be collaborating about Justin Bieber or something. The closer you get to being relevant to an actual technology consumer at the right time, at the right moment, the actual characteristics of what they're doing and what load they're generating changes pretty radically and pretty immediately. So it was going back about somewhere between 5 and 10 years, we started to build web-based experiences that were relevant in someone's immediate time frame. So it meant we couldn't map out some elegant business process flow for that we had a very predictable pipe towards when they'd be interacting with our servers. And then as soon as, probably the emergence of, really, really great smartphones, probably 4 years ago, they went from being a technology that people experimented with and technology savvy people really wanted them, to a very mainstream thing that was very integrated into people's lives. Right? People don't sleep more than an arm's length away from their phones anymore. It's become totally integrated into their life. What that meant is, if I think back to how did that change the way people interacted with businesses, 15 years ago, people checked their bank balance maybe weekly, right? They reconciled in a checkbook. Gave them internet banking. Suddenly they were checking, a few times a day. When people then had internet access at work, at home, etc., you went and you took that to, people checked 2, 3, 4 times a day. So you had in a couple of years an order of magnitude transaction. Take that to mobile, where they can wake up and they can get instant alerts on every spend out of their bank account, and you've got another order of magnitude scale, right? So we saw it with things like search properties, social sites, things like that several years ago, that people were interacting with them constantly. What we now see is that shift, and what drove that need for containers and that rapid development of apps and rapid scale up, rapid scale down in the data center, that's coming over to all these business applications now, right? So we can see what people had to build for social sites and mega scale web properties 5 years ago is now kind of relevant to almost every interaction that people have between them, between consumers, but consumer and the enterprise and employee in the enterprise, that they're constantly kind of interacting. And it's that technology that has matured, that maybe 10 to 20 companies, mostly Silicon Valley or tech companies in China and Japan, etc. There were maybe 20 companies in the world who were running that kind of sophistication by need because of scale. And now you see almost every business process being reinvented by this need to be always connected. And that reinvention is driving a level of traffic on the front end, where they're looking at kind of a more consumable version of that technology. I mean, what Docker did was take what 20 really smart companies were doing and figure out how to make it consumable for everyone through simplification.
Right. I'd like to talk about Docker in that context in a minute, but before I do, what you're talking about really are changes in patterns, correct?
Yeah.
And the patterns that have developed over a period of time speak to those examples that you give. What are the patterns that you recognize in how developers work that relates to the Docker and container ecosystem today?
Well, I would say the biggest change is in pattern. One is a move towards kind of experimenting with how their application touches the end user. and making very, very small incremental changes. We used to have very long cycles, and we do things like focus groups and a bit of design waterfall. Now, if you miss a trend in an application, and you don't experiment, and you don't have a pipeline that lets you get a feature out in a few days, you're going to become irrelevant. I mean, as a company or as a development shop, if you can't figure out how to push small changes frequently, you'll become irrelevant. So the change has shifted that people have to figure out how to take little bits of their code, test it independent of all the rest, because the systems have not become simpler in any way, right? It's still millions of lines of code and things like that. Mostly it's just packaged and tested differently, right? It's how do I take something that actually changes the way my application works and deliver it not as a big set of things, but as a small incremental change that I can test relatively independently. And then I can also continue to test it as I push it out, right? So I continue to get feedback as that code goes into a production site, and it's that kind of constant feedback loop, right? I'm not supporting code over hundreds of sites at hundreds of levels or anything like that anymore. I'm not getting back level. I'm staying current in terms of how my application is deployed globally, and I'm getting feedback from all of my different users and consumers, and I'm turning that into the next set of test cases, right? So that I call it kind of the DevOps transformation of how things should be built, anything that touches the end user. The cases where companies have got that wrong, whether it was things like mobile check deposit, where some companies didn't implement in their mobile app for years, or whether it's something like location-aware recommendations of where you can go get service performed on something you bought. The companies that haven't got those things right have actually suffered on the business side, right? Mm-hmm. So most development shops are retraining on how do we respond quickly to features that users want to see in our applications, and they've been taking this rigorous development process they built over many, many years and kind of flipping it around and saying we really have to figure out how to incrementally release features to all our customers. And I think that's actually more than anything that's given, it's not just a hey, we want to work differently reason, which is also true, but it's given a valid kind of we have to do this to survive as a company, so our developers have to work this way.
That idea about taking small bits of code and changing something, right? Mm-hmm. And being able to iterate, that seems like a way to think about microservices.
Yeah, absolutely. And I think we're seeing the beginnings of people figuring out how to build stuff faster, right? And we've seen that for years, shifting towards agile development procedures. But the shift to microservices, I think it's the ops side of DevOps that's really going to drive this, right? And that's where we know when a change is really succeeding or failing, right? I always tell people that we can talk a lot about what is a microservice versus what is a service and things like that. But I think the most fundamental thing is that developers need to think about instrumentation and how they spot success, right? And if you have a small piece of code and you can define metrics around it, right, and availability around it, and then you can define a test framework that relates to that, those set of characteristics, you can actually kind of micro-instrument all these bits of code to a point that where your bottlenecks are, what's succeeding, what's failing, what are people actually using, right? Are there parts of my infrastructure that are getting heavy demand, or my complex application? And it's that instrumentation, that knowledge feeding all the way back to development that is really changing things, right? If you throw your code over the wall and you hope that some operations team is going to run it elegantly and give you the right feedback, and even your end users are going to give you the right feedback, and most of us have learned that's kind of crazy. It goes through too many layers of kind of communication or telephone game transformation.
Yeah.
If a developer understands what is success or failure for the code they're writing, and actually gets direct feedback from their production environments to react to. They know whether or not they've got technical debt or whether they can start working on the next thing. So I think actually for a lot of people, there's some great practices in microservices. There's some architectural principles they should understand. There's that idea of writing 12-factor apps wherever possible and stateless front ends. All of those things are important. But if you don't get the instrumentation right, you're kind of flying without instruments,
right,
trying to figure out what to do next.
But at the same time, it's a conceptual framework that you need to do it effectively.
Yeah, I mean, there is a conceptual framework to get there, and there's even a technical framework that you should follow to get there.
But they obviously interrelate.
Yeah, they absolutely interrelate. And the thing I like about the new generation of kind of cloud technology we're seeing, maybe a little higher than OpenStack and infrastructure cloud, probably more up around the platform level or the container level, is that the technical architecture encourages you to work this way, right? So the reason a lot of people are finding success and simplicity using things like containers and Docker is it's an architecture that encourages you to get better at packaging your code in small pieces, at instrumenting your development pipeline, at using the same format as you roll towards production. It encourages you to think of your code as small bits you deploy. And then one area I think we really, as an open source community need to improve is probably on that instrumentation and orchestration side.
How so?
How so? Well, we see frameworks that work, again, for some companies, right? We see there's a lot of examples of, again, the sort of internet properties evangelizing how they have done microservices, and it works for their applications, for their business, right? But those generic frameworks that help people write all kinds of different applications that encourage them to think of their microservices as these API-enabled things and have a framework built into, their packaging model. We're not quite there yet, right? We're getting close. But just putting something in a Docker container doesn't mean you've necessarily API-enabled or built the right microservice. And it doesn't necessarily mean that you've instrumented it the right way and understand how your request counts and your API counts relate to, resources you're using in the container, et cetera. So I think we can go a little further in terms of, guiding people the right way.
How would you go further?
How would we go further? Well, we've already started down this path, at least, on the IBM side. When we pushed out this idea of containers, we're bringing in open technologies like Elasticsearch and things like that help you instrument your app the right way, get the logs out of your stateless container into some kind of searchable service, designing that container to actually feed metrics out of it. So that you actually get the hundreds of things you're managing in a microservice architecture into something you can run some analytics on and make sense out of the data that comes out of it. I think we're going to see that become sort of a standard pattern for how people build things, and now it's just kind of a matter of, I think, evangelizing and informing to a developer community about what it means to write instrumented applications. Mm-hmm. It's an area where a lot of people just didn't invest for a lot of years. They viewed running their production system as something, because compute cycles were expensive, they focused on all that testing and all that instrumentation before their production environment. Right? Now, the expensive part is not knowing what's going on in production. Right? So it's actually, there's a cost to all this metric, CPU cost, or whatever you want to call it, to all the instrumentation, the metrics, etc. But it pays off with insight, right? So that's sort of, we also have to retrain people who thought for a number of years that all that information you could get was useful in load test environments or integration testing, et cetera. And now we're saying, no, that detailed analysis in a lot of cases is most valuable by having it built into your application and built into your platform in production.
So it's that application-centric architecture that we're hearing about to some extent.
Yeah, it's very application-centric. It's very integration-centric as well. Because the other thing that happens was, is, we used to think of an application from a business perspective as something that we provided not just the API and the business logic layer, but also the full presentation layer for, right? And that we were in control of the total user experience. Well, what changes in sort of this API world we're entering is people reimagine the interaction model with the applications. So the way you think that someone is coming into your business or your business application, that flow may be reinvented tomorrow. Maybe it's something like, a watch-enabled notification or something like that. And someone writes a new hook and a new notification and event mechanism on the front end, and it changes the flow. It's not, we build the web page and we build the mobile app and no one else enters our business logic. What most people are having to figure out is, I've got to put awareness and hooks and monitoring flows not just at the front end of the experience of the customer, but at the API layer of those microservices and microservices as well. So that's actually I think what's really going to, I think we've talked for years about this idea of a virtual enterprise, right? I think what we're seeing now is the technology and also just enough different ways that people want to interact with the business that front end experience is changing rapidly, right? There's lots of these aggregators and mobile applications that interact with many businesses, almost completely virtual companies, and they're kind of taking over the user experience front end. On the back side of it, it's actually one of the biggest growth channels for a lot of businesses, right? It's providing whole new user experiences, whether it's augmented reality and retail shopping, whether it's social transactions and splitting the bill on the spot, at a restaurant on your mobile phone. All of those transactions, the back-end systems that were built, they never imagined those, right? The people who architected these systems 10, 15, 20 years ago, they never thought of that kind of interaction model on the front end. So they've had to think of this, sort of two-speed world. I've got my system and my stable running business, right? Mm-hmm. How do I transform that just enough to enable this super fast, changing world of consumer interaction on the front end? Mm-hmm. So it's really about kind of getting that right encapsulation, knowing how to slowly evolve the back end that really runs the core of the business, but then opening up all those APIs to a whole new set of integrations that they may never have dreamed of when they built the business or built the apps in the first place.
So how is this embodied in how IBM is addressing the community and the developer community specifically, and the ops community too?
Well, part of it is just that we've shifted a lot of our focus into a cloud platform, right? And that we actually.
So tell us about that cloud platform,
okay.
And how these new patterns are embodied, in what you are developing and building out.
Yeah. So that cloud platform. One big piece of it is that we made a conscious decision to build it all on open technology and primarily open source. The reason being is if developers are under pressure to build new things, we have to meet them where their skills are, right? And it became at least evident to most of us who were interviewing people coming out of universities, and most code's written by people under 30, right? 50 to 60%, depending on which country you go to. The developers do the bulk of their coding early in their careers before they shift into other roles. People have gravitated towards technologies like Linux, Docker, many different programming languages being used within those. So we had to think of a platform that enabled people to write in the language they wanted and then bind to a set of kind of core services. And we looked at technologies that were getting and ecosystems that were getting attention. So when we looked at the infrastructure layer, we saw a huge amount of kind of conversation, internet traffic, and forums getting excited about OpenStack. The platform layer, we saw similar excitement around CloudFoundry, and then in the packaging and kind of lifecycle side of things, we saw all this energy around Docker. So we actually decided to meet developers kind of where their communities were growing, and then build our platform, or our cloud platform, around that. So I'd say that was probably the most significant shifts for us, was to actually just, yes, we can accelerate these communities, and absolutely we, help initiate and contribute to those communities, but a big part of what we do is actually watch what else is happening, right? And we, as soon as we see that it's something that really solves a problem or enables, or it's become, popular, we try to make sure we accelerate those communities as opposed to kind of staying back from them. So I'd say that's probably a big part. Now the platform itself, again, to my earlier comments about microservices and instrumentation, a lot of what we've done, I would say, is enable people to build stuff the right way.
Yeah.
Build it so it will scale. Like if we can learn from the transformations we went through, getting from the static web to the dynamic web to kind of the e-business era to the mobile transaction world, the design patterns for a lot of those pieces have stayed the same. Right? The speeds and feeds are much higher that we have to get to, but the design patterns we learned on how to scale over the years haven't changed all that much. The difference is making it really convenient for people to build on those, right?
Is this new era, the developer era then, that we're seeing, if we looked at, it from the historical perspective that you did? I mean, and I think you could theoretically argue that almost every person on the planet has had some contact with the internet, whether they know it or not.
Yeah.
And that means that millions of people will be developing, will be developing to program, the internet in some regard, so they can be able to do different things and be able to, offer new kinds of services to take advantage of new kinds of patterns. Would you arguably say that this is the new developer era, or is it something else?
Well, I think to a great extent it is a new developer era, but I think also what a developer is changing as well, right? And in the speed we worked at before, and just the kind of cost of providing hardware to run an internet site or something means we used to segment our teams quite a bit. Right? We used to have developers do very specific things. We used to have testers do very specific things. They used to get to a point of stability and hand it off to operations, and they watch the dashboards and things like that. And they had a set of activities they would run. I would say what's changed is yes, it is very much an era that is developer focused, but it's also an era where the developer is taking on a lot more responsibility for their code, which means they take on a lot more responsibility for test and feedback from operations, and a lot of companies even potentially hands-on in operations. So I think that's kind of, to me, that about a year ago, I think we understood how much influence developers had started to have, because there is a whole new set of applications we're writing, right? That whole front-end engagement and that whole, sort of cognitive computing era where we're getting a lot more analytics out of a lot more data. One of my favorite numbers I always hear is that, in the Internet of Things, or the very instrumented world we live in, we throw away about 99% of the data. Today it's just noise, right? Whether that's from hygrometer or water sensors out in an agriculture field, or vibration sensors on a car, there is so much data that we actually throw away most of it, right? Now, if we actually shift the role of developer and the data scientist to actually deal with all that data, right? There's a huge set of applications we haven't touched. But those applications aren't going to be written in 2-year development cycles, and there's no operations team who's going to reach out and operate the individual sensors in this world. So we have to write our solutions a little differently. And in some senses, the developer takes a lot more ownership of that code all the way out to where it's running at scale.
And so that's the importance of these concepts about microservices and concepts about new application architectures, because the developer who will live in this world and will be developing in this new world will not want to deal with the complexity that we have to deal with today.
Yeah, I mean, it's simplicity, things like unattended automation of their deployments, as their code is deploying and getting put into service next to the code that they, just finished maybe a few days or even a week before. They need all that instrumentation to tell them, is the new stuff I've just written succeeding in a way that it's going to replace the old stuff? And old being something that's days old, not weeks or months or years, right? So it's that kind of sophistication. And instead of having a whole bunch of segmented, fine-grained roles in terms of building and deploying and operating applications, we're finding that, automation is kind of flattening to some extent that definition of what all those different roles were in writing something. So it's a combination of skills of, new kind of developer, much more test and operations aware, and then a platform that enables them to be efficient, that actually provides some of that automation for them, that provides some of that instrumentation for them, gives them the hooks to do, analytic processing of their instrumentation and all that data that comes from that. So it's very much a new world, but it's actually, for us, it's really an exciting world because it's actually bringing, instead of doing back office innovation on, accounting systems and, systems of record and databases, we're innovating at the edge now, where technology really touches people and real world things. And, we're coding all the way out to those solutions now. So what we're going to be building in the next few years, I don't think any of us know. What we do know is we're going to be building it differently. We're going to be building it on cloud, and we're going to be automating the delivery of this code all the way out to the edge.
And so when we speak to these developers who are, who will see emerge and who will see, building applications in different kinds of ways, what do we see in the Docker and container ecosystem that's evident of that? I think it's not just the Docker container ecosystem either. It's in the, the popularity of JavaScript and the popularity of Node.js. What is it that you see today that is evident of the shift that will reflect on the direction that, the developer era proceeds?
Yeah, I certainly agree with you. That I think it's bigger than just the packaging, ecosystem and the container ecosystem of Docker. Probably, and I'll come back to Node and JavaScript and other languages in just a second. But I would say the thing that strikes me as most interesting is sort of this era of aggressive experimentation, and when I actually, when we used to bring in a developer, we would spend a month sort of onboarding them, right? We would teach them about our architecture, we would teach them about our standard tools, like, you will use this development environment, you will use this build tool, this is our release schedule, this is our test. We would train them, almost retrain them ground up. What I see happening now is often a developer comes in, they come at a problem, and then they go and ask their friends, they search the internet, and they find whatever they think is the best, leanest tool, package, whatever, to get the job done. Which means a lot of that other stuff we don't spend as much time on. Right? Yeah. We don't tell them how to work. We don't tell them, in some cases, what language to write in. They'll go kind of figure out what other people might be doing to solve the problem. So I'd actually say the biggest shift is that we have all of these little communities, the hundreds or thousands of GitHub projects around open source, where you get small communities forming around a problem. And if it turns out it's something that lots of people are struggling with, it immediately becomes a large community through sort of word of mouth and forum information, social exchange, etc. So I would say a lot of what we think is different is that social coding aspect, right? That we're not all solving things behind our corporate firewalls and in our locked offices. There's a lot more interaction out to solve problems, and people are more willing to accept problems that someone else has already solved for them in the form of code. Now, the programming language thing, kind of, we asked about Node and the communities there. I mean, there are programming languages that suit themselves better to specific pieces of the problem. And when you don't mandate to your entire organization or to your entire team that you should only use one programming language, we found a similar thing, that people will gravitate towards a language that suits the kind of problem they're solving.
Right.
Take command line tools, for example, right? Very, very rapid, I guess you could call it, trend that came up was people writing that in Go. Because they're fully encapsulated, fully built, they don't have outside dependencies, etc. So we saw a big shift in people who were building command line tools writing in that language. And when people figured out it made it easy, it made it quick to build, etc., they went through the learning curve to understand the language and start writing in it. As people were building mobile applications where the front end of it might be written in JavaScript, they realized, well, hey, if all my data processing for the front end of this thing is going to be in JSON, maybe some of the back end should be in JSON, or maybe I want to take advantage of some of the things in Node.js in terms of how it handles the interaction model from the web. So what we've seen on the language side is that people will use, and if I think of an application as an end-to-end thing, all the way from a existing system to a new interaction, people will actually use multiple programming languages. And what we're having to figure out is how to enable people to do that and then stitch them together into sort of one coherent operating environment. So I think that's kind of been the interesting shift for us, is we have to figure out how to make a platform relevant in that polyglot, multi-language world, where the complete experience that actually touches the end user of an application may have many, many different languages and bindings behind it. And I kind of view it as our job, building a cloud, to stitch those services and microservices and data services together in a kind of coherent model, right, so that it runs. So that's actually it's been enabling that social coding, enabling that choice of language is kind of the challenge that we're trying to step up to.
So it's that polyglot community that people are attracted to, because they just want to be able to solve the problems they can. For example, they can use the internet to figure out how to use those programming languages. Then it seems then like what the Docker and container ecosystem provides is the quickness, right? Is that speed? It's that lightweight factor that speaks to the movement that encompasses not just itself and its own, but like it's part of a larger drive, a larger kind of movement toward finding ways to use the tools properly and do it fast.
Yeah, and help me. I wrote some code and it's in a different format than maybe you were used to putting in production, but let me get consistent on how I package it at least, right? So I think a lot of it is that consistency of packaging that we were looking for, and then the density of it, right? Not everybody. The challenge with the sort of the virtual machine era of that is people were packaging a lot more than their code and giving it over to some operations team, right? To get my code out there, I don't need to give you a whole operating system. I just need to give you my code, right? So it actually solved that neat problem of how do I package this stuff in such a way that it's small, it's lean, and it reflects, what I wrote, not a whole bunch of other stuff that came with it because of a packaging choice that somebody else made.
And I guess the one, there's a lot of other questions that we could discuss that relate to application architecture changes and microservices. I'm thinking of networking and storage, issues that we're starting to see emerge. That's a back-end issue, really, that the developer doesn't really or shouldn't have to deal with. What is your guys' thoughts on that? I mean, we're starting to see these micro networks, emerge, which allow for developers just to be able to use something without, without having to go underneath the cover, so to speak, you'd be able to understand how the actual networking works and how it, how it integrates with their applications.
Yeah. So, I mean, the networking side of it, I would say a lot of what's changing is how to make the network more programmable to match the life cycle of the application. Right? That's a big shift from where we were, where we used to, tell applications they had to fit either in a very simple network, or they just had to be, written differently when they got into production environments, or treat the network differently. So now we're trying to figure out how to make, while keeping network security principles, et cetera, we're trying to figure out how do we make the network react to the life cycle of the application? How do we make the network scale in response to the application scaling? And those things. So that is a little different maybe than some of the challenges we see in storage, where there's a volume challenge that we're going into, right? There's a whole lot. Again, I think I commented on earlier that a lot of the information we generate today, we don't store it. We often just throw it away, right? The more people want to analyze that extra information, or maybe turn it into more useful information at the edge and bring it back, the more we'll continue to see that sort of explosion of storage that has to be accessible to applications, right? And it's not about burying it somewhere where you can't actually run any kind of analytics on it. It's actually a lot more kind of real-time access to do, some decision making or rapid analysis over information before it goes into, just sort of audit or
which speaks to the need for services more than anything, right?
Yeah.
I mean, the need to be able to abstract all that complexity, so you just have the information for what you need to know, right? The cost or the consumption on whatever it might be.
Yeah, certainly. There's it's almost this idea of in-place analytics. A lot of what we did in the current world is we very much optimized the transaction, and then we looked at things like fraud detection as a process that kind of ran off to the side or offline or on some archive of the data. And now we're looking at streams of information and processing them either as they pass by, which is a bit of a new application model of how do you bring the services closer to the data, and how do you enable that kind of application programming. And then there's the other part of it is, how do you make the data that was sort of sitting at rest accessible to analytics applications in a way that doesn't interfere with the core processing and core transaction you've always had to run. So those are sort of new models where we're moving a lot more data around to serve analytics applications. And that's actually something, in addition to packaging the application differently, we got to get a lot better at expressing out of an application what kind of access does it need to the data flowing around it, or the data that's existing somewhere else, maybe in an enterprise database or something.
I think we should save that conversation about the data for another time. I think it's a whole topic in itself.
Yeah, absolutely.
And so I just would like to thank you for taking the time to talk to us about the historical context for the Docker and container ecosystem, and its with some perspective on the past that we're going to see going forward. So thanks, Andrew. Thank you very much for taking the time.
All right, thank you, and I hope you enjoy the rest of the conference.
You too.